At first, a summary. Polyethylene pipes in the field are joined to each other by butt welding. After planing, a heat plate between the pipe ends melts them. After removing the plate and pressing, the weld evolves with a seam. The weld has to be tested non-destructively. Microwave testing can do this. A special adapter is pushed onto the handheld probe to ensure a wobble-free movement. Defects in the weld give clear indications. This tutorial is very application-oriented. It shows the application of another matching adapter to the handheld probe, this time for the test of the butt weld of polyethylene pipes. PE pipes are used for various applications, for example, for gas and water distribution, as well as drainage and in sewer systems. Rods of these pipes of 6 or 12 millimeter length are to be joined in the field by butt welding. And these welds have to be tested non-destructively. In the following, we first see some scenes from the butt welding of the PE pipes. Here are the two pipes which are to be joined. They are aligned. The ends are planed. A heating plate is inserted between the ends. These are pressed together. The beads start to evolve. When enough heating is done, the two pipes are briefly pulled apart. The heat plate is removed and the two pipes are pressed together again. The beads grow, the seam gets its final shape. The cooling down follows. The double weld seam around the pipe hardens. In the following we see how it can be non-destructively tested for structural integrity using microwave testing. Here we see a short piece of a butt welded PE pipe. When we take the probe, the handheld probe with the planar antenna and move it across the seam to test it, we see a very bad noise. This noise stems from wobbling of the probe, and this noise would cover the defect signal, which usually is rather weak. To suppress this background noise, we use this adapter which we see here. It consists of these two rails of concave cylindrical shape, which well fits on the convex cylindrical shape of the pipe. And the adapter has this housing around the seam without touching it. Then we move the adapter onto the planar antenna, and we do the test again. And we see that there is practically no movement, a very smooth signal. Well, this was done at a situation where there's no defect inside. To simulate a defect, I now take this very tiny plastic particle and insert it into the inner part of the weld seam, where it is pasted right now. And I repeat the movement, and we see a strong deflection here, which goes back then. And I return the movement. Here's the maximum just over the defect, and then the signal goes back. We have seen the deflection over the defect with the well-known spirals at the root. I remind you, we have seen the applications of adapters to the handheld microwave testing already before. This is the link in the upper right corner. In the present video, we saw another application, namely the non-destructively test the butt welds of polyethylene pipes. That's it for today. Thank you for watching. See you next time. Goodbye.